go further, one thing about the formulas is that these formulas can be used in reverse, and the formulas can also be manipulated. Okay, and what I mean by manipulated is that the rules of algebra are still pertinent for this course, which means that, for example, in the properties of equality, whatever you do to one side of the equation, you must do the other or the exact same thing to the other side of the equation. So, for example, if I were to take this, let's say this sum of cosine formula, and if I were to multiply the left hand side by 2, I would also multiply the right hand side by 2. And by doing that, you can maintain equality. Now, we're going to see as we work through problems in this session that there's some of the problems you're actually given the problem in reverse, which means you're actually given this right hand side. And based on the right hand side, you have to evaluate or determine the value of the right hand side. All right, so we're going to see how that breaks down. I'm going to go to OneNote for just a second. All right, and I'm going to pose a problem. Now, I've noticed in just in the problems in general in the trig course, some of the problems will generate a similar answer, and in other problems, they're just kind of do whatever. So in this example, we're going to evaluate or find the exact value for the sine of negative 7 pi over 12. Okay. So now on the last class, when I kind of looked through the homework problems, I didn't see any problems that had like a negative. But now I'm kind of looking at the problems today, and in some problems, you may see this negative angle deal pop up. So just remember from our negative number identities, and unfortunately, the only place the negative number identities can be found are, I believe it's in the lecture notes. And I believe it was 9.2. No, I'm sorry, it was 9.1. Yeah, notice we have the negative number identities, right? So if we're trying to find, let's say, the sine of a negative angle, we can actually write that as negative times the sine of a positive angle. All right, so whenever you're encountering these negative angles and you're asked to find the exact value, you can rewrite your negative angle as a positive angle. All right, as we're going to see in this example. All right, so we want to find the sine of negative 7 pi over 12. Okay, in proceeding, I'm going to simply use the negative number identity, and I'm going to write this as a negative times the sine of a positive 7 pi over 12. In this instance, I'm going to convert 7 pi over 12 to a degree measure. All right, because our final result, it's not in radians and it's not in degree measure. Our final result is the actual exact value, right? And it's easier on the brain to think in terms of degrees, right? So I'm simply going to convert 7 pi over 12 radians to degrees. And then we'll use the unit circle. Okay, and from the unit circles, we can pull out the angle measures that we need. So in order to convert 7 power over 12 radians to a degree measure, I'm going to multiply 7 times pi, right? And pi radians as a degree is equal to 180 degrees. I'm going to divide this by 12, and we have 105 degrees. So I'm going to rewrite this as negative times the sine of positive 105 degrees. All right, so notice that there is a negative in front of our sine function. Okay, I'm going to pull up the unit circle. Right, and if we look at the unit circle, notice that there is not a 105 degree angle, but we can use a combination of angles that would give us 105 degrees. So in this instance, I'm going to use the 60 degree angle and a 45 degree angle, right? Because 60 plus 45 is equal to 105. So I'm going to rewrite this as negative times the sine of 60 degrees plus 45 degrees. Now, when you're writing this out, it really doesn't matter which value you put first. You could put 45 degrees first. You could put 60 degrees first. That doesn't matter. The only thing that matters is that your combination gives you the desired angle measure, which in this case is 105. All right. So looking at our setup, we're going to use the sum of sine formula. All right, so referring back to our formula sheet, all right, here is the sum of sine formula. The sum of sine is equal, the sine of A plus B is sine A plus sine A times cosine B plus cosine A times the sine of B. Now, in this course, you're not required to memorize the formulas. You only need to know how and when to use the formulas. All right, so we won't have to memorize, so I'm simply going to rewrite this formula right above our given problem. All right, so the sine of A plus B, that's equal to the sine of A times the cosine of B plus the cosine of A times the sine of B. Right, so in this formula, we're going to substitute A for 60 and B for 45. But remember, we still have a negative in front of our sine function. All right, so be sure to carry your negative. And now I'm just going to simply substitute in the values. So we have the sine of A, which is 60, times the cosine of B, which is 45, plus the cosine of A, which is 60, times the sine of B, which is 45 degrees. All right, from this point, we're going to pull out, and notice I'm bringing down my negative. We're going to pull out the values for the sine and cosine of 60, as well as the sine and cosine of 45 degrees. And I remember there's two ways that we can find these values. We can use the unit circle, right? And if we're using the unit circle, the x coordinate represents cosine, the y coordinate represents sine, or we could use I'm going to go back into formula sheets, and I'm going to pull up the unit circle function values chart. Right, or we can use this document, right? We can find the cosine and sine of both 60 and 45. Right, so looking at one or the other, we see that the sine of 60 degrees is 1/2 times the cosine of 45 degrees, which is square root of 2/2, plus the cosine of 60, which is square root of 3/2, times the sine of 45 degrees, which is square root of 2/2. I'm going to bring down my negative. Right, we have the first term and the second term. Right, so in the first term, we're multiplying fractions. So when we multiply fractions, we multiply the numerator and the denominator. So we have the square root of 2/4. And for the second term, we're going to multiply the numerators. The square root of 3 times the square root of 2 is the square root of 6 over 4. Okay, I will answer that in a second. All right, and then we're going to distribute the negative. So we have negative square root of 2/4 minus square root of 6/4. All right, and I'm going to check the solution just by using the calculator. All right, now our initial problem was given in radian measure. So I'm going to just make sure that my calculator is in radian mode. All right, so I'm going to go into mode. All right, I'm going to change that to radian. So I'm going to put in the sine of negative 7 pi divided by 12. All right, and we can see our value is negative 0.97. And next I'm going to just put in the values that we calculated. And it re-erased on me at the end. All right. Okay, OneNote's been crashing. I don't know what's wrong with OneNote. All right, so I'm going to put in a negative square root of 2. I'm going to close off my square root, right, divided by 4 minus, so remember I did distribute that negative, minus the square root of 6 divided by 4. All right, and we have the exact value. So just remember, just to reiterate, here's the difference between an exact value and an approximated value. The calculator will give us an approximated value. Okay, the exact value, okay, since the square root of 2 is an irrational number, and an irrational number, it never stops and it never repeats. So it's impossible to write out the square root of 2 approximately because it never stops. You keep writing it forever. The exact value is encapsulated in the square root of 2. All right, so when you're answering the problems and it asks for an exact value, normally that means that there is a square root somewhere in your solution. Okay, doesn't always mean it, but most of the time it means that there's a square root in your solution, and the only way to express that exactly is symbolically. All right, now we're going to take a look at the tangent. Right, so I believe we've taken a look at the sum and difference of cosine and sine. let's see where it was. Okay, if I believe we're taking a look at the sum of cosine, we've just taken a look at the sum of sine. Now we're going to take a look at the sum and difference of tangents. Okay, now when we talk about the sum and difference of tangents, on the majority of these problems, I can say all of the problems, we're going to have to do what's called rationalize a denominator. All right, so here is the example. We're going to find the exact value for the tangent of 7 pi over 12. Okay, so based on the previous problem, that 7 pi over 12, if we were to convert that to a degree measure, we would get 105 degrees. All right, so once again, it's just 7 times 180 divided by 12. All right, so notice that's the same 105 degrees. All right, so if we look in the unit circle, notice that there is no 105 degree measure. All right, so we're going to basically do what we did with the sine function. I'm going to use 60 and I'm going to use 45 degrees, right? So I'm going to rewrite this as the tangent of 60 degrees plus 45 degrees. All right. So I'm going to look back at the sum of tangent formula. Right, and the sum of tangent formula says that the tangent of a plus b, that's tangent a plus tangent b, divided by 1 minus tangent a times tangent b. Right, so I'm going to just write that above my problem. So the tangent of a plus b, that's equal to tangent a plus tangent b divided by 1 minus tangent a times tangent b. Right, so in this formula, we're going to substitute a for 60 and b for 45. All right, so this is equal to the tangent of 60 degrees plus the tangent of 45 degrees divided by 1 minus tangent of 60 degrees times the tangent of 45 degrees. All right, so now we need to find the tangent for both 60 and 45. Right, so the quickest way to find tangent values are by using the unit circle function value sheet. All right, so if we look at 60 degrees, which is here, the tangent for 60 degrees is square root of 3. If we look at 45 degrees, the tangent is 1. All right, so I'm going to just replace those values All right, in our problem, so we have the tangent of 60 degrees, which is the square root of 3 plus 1 divided by 1 minus, right? The tangent for 60 degrees is square root of 3. The tangent for 45 degrees is 1. If we were to multiply those two, we would have the square root of 3. All right. All right, so just remember that we must rationalize the denominator. All right, so remember when we deal with square roots, we have what are called conjugate pairs. All right, so just to kind of review that, a conjugate pair all right, so here we have the term, and over here we have the conjugate pair. So let's say we have 1 minus the square root of 3. So in order to find the conjugate pair, you only change the sign of your second term. So the conjugate pair for the term 1 plus square root of 3, excuse me, for the term 1 minus square root of 3 would be 1 plus square root of 3. So let's just say our term was negative 1 minus the square root of 3. Its conjugate pair would be negative 1 plus the square root of 3. Right? Only the sign for your second term changes. Right? So let's say we have 2 plus the square root of 3. Its conjugate pair would be 2 minus the square root of 3. All right. So in this case, we're going to multiply both the numerator and the denominator by the conjugate of the denominator. So the conjugate of the denominator is 1 plus the square root of 3. Right? So remember, whenever you multiply or anytime you divide anything by itself, this value is 1, right? 1 plus the square root of 3 divided by 1 plus the square root of 3, that should equal to 1. Anytime you multiply something by 1, you don't change the value. You simply change the way that your problem is expressed. All right. So from this point, we're going to multiply the numerators and we're going to multiply the denominators. We're going to cancel, and we should have our final result. All right. So now there's a couple of formulas from algebra, and it should make the math on this a little bit easier. So I'm going to just kind of go through some of these formulas. So we have a plus b quantity squared, right? And if you look close at the numerator, the square root of 3 plus 1, right? If we were to reverse the terms, exactly the same as 1 plus the square root of 3. Okay. So in the numerator, we could use this formula, right? A plus b quantity squared, that equals to a squared plus 2ab plus b squared. Right? Which means that if we have 1 plus the square root of 3 squared, right, I can substitute a for 1 and b for the square root of 3. So if we were to use this formula, a squared would be 1, right? Because 1 squared is 1, plus 2 times a times b. So 2 times 1 is 1, 2 times square root of 3 is square root of 3. So that's 2 square root of 3. Plus, if we were to square the square root of 3, right? The square root and the square cancel, and we would have 3. And then we can combine like terms for 4 plus 2 square root of 3. Right? I could also full method this thing out. All right. Now I think the better algebra student would probably do it this way. Okay, but I'm just going to FOIL it out just to show you both methods. So this would be using the FOIL method. So 1 plus the square root of 3 times 1 plus the square root of 3. Right, I would multiply my first terms. 1 times 1 is 1. I would multiply my outermost terms. Right, 1 times square root of 3 is square root of 3. I would multiply my innermost terms. The square root of 3 times 1 is another square root of 3. I will multiply my last terms. Right, the square root of 3 times the square root of 3. That would give me the square root of 9. Right, and the square root of 9 is perfectly 3. Right, and then I will combine like terms. So 1 plus 3 is 4. 1 square root of 3 plus another square root of 3 gives me altogether 2 square roots of 3. Right, so that's our numerator. That's equal to 4 plus 2 square root of 3. In the denominator, we have a sum and difference of binomial, and there's a formula for that as well. All right, so I believe that would be a plus b times a minus b. That's equal to a squared minus b squared. So if we have 1 plus the square root of 3 times 1 minus the square root of 3, right, I can substitute a for 1. Right, so 1 squared is 1. I can substitute b for square root of 3 in the formula. So the square root of 3 squared, the square root and the square cancel. I'm going to bring down my minus, however. The square root and the square cancel, so I'm left with 3. So 1 minus 3 is negative 2. Right, so our denominator should be negative 2. All right, or I can FOIL it out. I'll actually FOIL that out. All right, so, okay, that's using the formula. We can FOIL that out. So 1 plus the square root of 3 times 1 minus the square root of 3. All right, we can multiply the first terms. Right, 1 times 1 is 1. We can multiply the outermost terms. One times, well, a positive times a negative is a negative. 1 times square root of 3 is square root of 3. The square root of 3. We can multiply the innermost terms. We get a positive square root of 3. Right, we can multiply the last terms. A positive times a negative is a negative. The square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 is perfectly 3. So we're left with 1 minus 3, which is negative 2. right, so we have negative 2. Okay. Now, lastly, we're going to simplify this. So remember the last time we talked about the divide by a monomial. And as I kind of mentioned, this is not really an algebra course, but it's sort of algebra heavy. So I'm just kind of reviewing some of those formulas from algebra. So the divide by a monomial states that a plus b over c, that's equal to a over c plus b over c. Right? We can rewrite each term having a denominator negative 2. So I'm going to write this as 4 over negative 2 plus 2 square root of 3 over negative 2. All right. Now, one thing you don't want to do in this case is just straight cancel. All right, because that violates our formula. All right, so notice I'm splitting it up first, and now I'm going to reduce. So 4 divided by negative 2 is negative 2. Right, a positive divided by a negative is a negative. And one node has crashed again. All right, so that's it's crashed again. Okay. I think I have to delete some of my tabs or something because I never erase these things, and I believe that's what's causing the problem. I have so many tabs open, I think that is the cause of the problem. And has it disappeared completely? Okay, I don't know what happened to the problem we were working on. I'm going to do the next one using the camera. Sorry about that, but I believe it was negative 2 minus, was it the square root of 3? Boy, I apologize for this. I believe it just crashed and deleted the entire page I was working on. All right, so that was the tangent of 105, I believe. So I believe in the top we had four plus 2 square root of 3, I believe. In the bottom we had 1 minus 3, which is a negative 2. And then we have 4 divided by negative 2 plus 2 square root of 3 divided by negative 2. I believe we should have negative 2 minus the square root of 3. Okay, so let's check this with the calculator. All right, so we had, just make sure that I'm in radian mode. Well, since I'm in degree, I'll use degree. So we had the tangent of 105 degrees, so that's the tangent of 105. The tangent of 105, which was negative 3.73. Next, I'm going to evaluate negative 2 minus the square root of 3. Right, and we have the exact value. And I believe for the next problem, I'm going to switch to the camera, the document camera. And when we meet again, I just have to go in and clear out all of these tabs I have open. I believe that's the problem. I never close these down, so I think that's maybe the reason why this thing is crashing. Okay, but I got to save some of these first. So, all right, so we're going to go back to XYZ homework. All right, and we're going to continue down. Now, for problem number 3, I would like for you to work this problem. All right, the tangent of negative pi over 12. All right, so at this time, I'll give you a few minutes to work out the solution for this, and then we'll return with the solution. Okay, I had to log out and log back in so my camera could connect. And I'm going to admit that this is probably one of the most difficult problems. Well, not difficult, but one of the most involved problems in this section. So we have the tangent of negative pi over 12, right? And we want the exact value, so we're going to, I'm just going to convert negative pi over 12 radians to a degree. So this is equal to the tangent of negative 15 degrees. I'm going to use the negative number identity. I'm going to push the negative in front and express this as negative times the tangent of a positive 15 degrees. All right, so if we look in the unit circle, there is no 15-degree angle, but we can subtract two angles to get 15. So I'm going to use the 45 degrees and a 30-degree angle. All right, so I'm going to rewrite this as negative times the tangent of 45 degrees minus 30 degrees. All right, so in this instance, we're going to use the difference of tangent formula. Right, so above the problem, I'm just simply going to write the formula. So we have the tangent of A minus B. That's equal to tangent A minus tangent B divided by 1 plus tangent A times tangent B. Okay. All right, so here again, this can be pulled from the formula sheet. So in the form, I'm going to substitute A for 45, and I'm going to substitute B for 30. Okay, so this is equal to, so keep in mind there's still a negative, right, in front of our tangent. So it's negative times the tangent of 45 degrees minus the tangent of 30 degrees divided by 1 plus the tangent of 45 degrees times the tangent of 30 degrees. All right. So keep in mind we still have our negative. And we can pull the tangent values from the unit circle function values. So the tangent of 45 degrees is 1. The tangent of 30 degrees is square root of 3 over 3. So in the numerator, I have 1 minus square root of 3 over 3. And in the denominator, I have 1 plus square root of 3 over 3. All right, because tangent of 45 is 1, the tangent of 30 is square root of 3 over 3. So when I multiply the two together, I get square root of 3 over 3. All right, and now we have to rationalize this denominator. Okay. So what I'm actually going to do here is the first thing I'm going to do is I'm going to get rid of the fractions that are in the numerator and the denominator. And the way I'm going to do that is I'm going to multiply both the numerator and the denominator by the least common denominator. So I'm going to look at all four of my terms and I want to determine the least common denominator. Now in this instance, okay, I only have 3 in the denominator. So my least common denominator is actually 3. All right, so here again, that's that specialized form of 1. Anything over itself is 1. So when I multiply this by 1, it doesn't change the value. It simply changes the way that it's expressed. All right, so I'm going to distribute 3 in the numerator and I'm going to distribute 3 in the denominator. All right, so keep in mind we still have our negative. So 1 times 3 is 3 minus, when I multiply 3 times the square root of 3 over 3, the 3's cancel, and I'm left with the square root of 3. When I distribute 3 in the bottom, I have 3 plus the square root of 3. All right, so the only thing I did here was I got rid of the fraction in the numerator and the fraction in the denominator. Now I must rationalize the denominator. All right. Okay, so I'm going to switch to another page. Okay, and I'm just going to transfer that up here. So I have negative 3 minus the square root of 3 divided by 3 plus the square root of 3. All right, so now I'm going to multiply the numerator and the denominator by the conjugate of the denominator. All right, so I still have my negative in front. All right, so I'm going to multiply the numerator and the denominator by the conjugate of the denominator. So the conjugate of 3 plus the square root of 3 is 3 minus the square root of 3. All right, so for the numerator, right, I have 3 minus the square root of 3 times itself. Right, here's another formula from algebra, and it says that A minus B quantity squared, that's equal to A squared minus 2AB plus B squared. Right, so if we were to multiply 3 square root of 3 by itself, right, so I'm on a square A, so 3 squared is 9, minus 2 times A times B, so 2 times 3 is 6. 6 times the square root of 3 is 6 square root of 3. Right? I can't multiply the 6 and the 3 because this 6 is not a square root. Right? So I will express it as 6 minus the square, 6 times the square root of 3. And then I can take B, which is square root of 3, and I'll square that. So the square root and the square cancel, and we have plus 3. So if I combine my like terms, I have 12 minus 6 times the square root of 3. Right. Now I'm going to kind of bypass foiling that out, right? And I'm just going to use this formula. Right, so we still have our negative, and in the numerator we have 12 minus 6 times the square root of 3. In the denominator, we have a sum and difference of a binomial, 3 plus the square root of 3 times 3 minus the square root of 3. So the other formula we were using was A squared minus, A plus B times A minus B is equal to A squared minus B squared. All right, so if we have 3 plus the square root of 3 times 3 minus the square root of 3, I can substitute A for 3 and B for the square root of 3. So if I were to square A, which is squaring 3, I would get 9. Okay, minus, because that's a part of the formula. If we were to square B, which is the square root of 3, the square root and the square will cancel. So the square root of 3 squared is 3. And 9 minus 3 is 6. So we have 6 in the denominator. So now I'm going to use the divide by monomial theorem. Okay, making sure to keep the negative. So we have 12 divided by 6 minus 6 square root of 3 divided by 6. 12 divided by 6 is 2, right? Minus the 6's are going to cancel. That leaves the square root of 3. I'm going to distribute the negative for a result of negative 2 plus the square root of 3. All right, so that was a pretty involved problem dealing with reducing that fraction down in the numerator and denominator and then rationalizing the denominator. All right, so we're just going to check the result with the calculator. So I'm going to switch screens here for a second. All right, so I'm just going to make sure my calculator is in radian mode. All right, so I'm going to put this in as a tangent of negative pi over 12. And I'm going to put in negative 2 plus the square root of 3. Negative 2 plus the square root of 3. Right, and we have our result, negative 0.26. All right, so that was about the most difficult problem in this section. I noticed on some of the problems, it was just kind of flop from a positive to a negative. All right, now going further down into the homework, for problems like these, you would just simply use the difference of sine formula, right? And you just substitute A for x and B for 2 pi over 3. So let's take a look at this one. All right, so this is the sine of x minus 2 pi over 3. All right, so we're going to use the difference of sine formula. All right, so I'm just going to write that difference of sine formula over our problem. So it says that the sine of A minus B, that's equal to sine A times cosine B minus cosine A times the sine of B. So in this formula, we're going to substitute A for x and B for 2 pi over 3. All right, so this is equal to the sine of A, so I'm going to substitute A for x times the cosine of B, so that's the cosine of 2 pi over 3 minus the cosine of A, so again we're going to substitute A for x times the sine of B, so that's the times the sine of 2 pi over 3. Now I'm going to evaluate. Now, since x is unknown, I can't actually evaluate this. I would simply have to leave this as the sine of x. However, I could evaluate the cosine of 2 power over 3. Right? I could use a unit circle, or I can use these unit circle function values. Okay, so if you look at the unit circle function values, 2 power 3 is 120 degrees, and the cosine is negative 1/2. So that's negative 1/2 times the sine of x. Right? Because I can't evaluate the sine of x because x is unknown, but I can evaluate the cosine of 2 power over 3. Minus, I'm just going to bring that down. So here again, I can't evaluate the cosine of x because this x angle is unknown. However, I can evaluate the sine of 2 power over 3. So using your unit circle function values chart, the sine of 2 power over 3 is square root of 3 over 2. Right? And this is as far as we can go. All right, so that solution is negative 1/2 times the sine of x minus the square root of 3 over 2 times the cosine of x. Okay, let's see. I have too many windows up. Okay, and for time's sake, I'm just going to bypass putting that in. And we'll take a look at one very last problem. And on these problems, let's see, 8, 9, 8 and 9, right? We can work the problems in reverse, okay, or look at the formulas in reverse. So we take a look at problem number 8. Right, we're asked to simplify. So we're given the sine of 8x times the cosine of 6x minus the sine of 6x times the cosine of 8x. So in order to simplify this problem, I'm going to try to bring up both two screens here. Oh, no, don't do it to me. And I'm going to bring up the formula sheet. Okay, give me a second. I'm going to get it together here. Okay, here are both pages up together. All right, I'm simply going to look for the formula that has this pattern. All right. So notice our problem is a sine times a cosine minus a sine times a cosine. Right, so if I look at my forms, it seems as though the difference of sine formula fits that pattern. Right, we have a sine times a cosine, right, minus a cosine times a sine. Right, so I've written the problem down. So I'm going to go back to the camera. All right, so here's the problem. And above the problem, I'm simply going to write the formula. All right, right, so the formula, and I'm going to write it in reverse. So the formula says the sine of A times the cosine of B minus the cosine of A let me make sure I wrote the problem down right. Okay. The sine of 8x times the cosine of 6x minus the sine of 6x times the cosine of 8x. Okay. All right. So that's minus the cosine of A times the sine of B. Okay. So I notice they're kind of playing some tricks on writing this out. So A is 8x. All right. And notice over here, A is 8x. B is 6x. Right. So they just kind of reverse some things over here. Right. But the formula says sine A times cosine B minus cosine A times sine B. That's equal to sine of A minus B. All right, so in the formula, I'm simply going to substitute A for 8x and B for 6x. So that's the sine of 8x minus 6x, and 8x minus 6x is 2x. Right, so our solution here is the sine of 2x. And one thing I've noticed is you must put the argument in a set of parentheses. And here's what I mean. If I were to just put the sine of 2x, it was probably marked incorrect. You just want to make sure you put your argument in a set of parentheses. All right. All right, so I think we're going to stop here for today. And I'm going to stop the recording.